Hello. Today I'm going to talk about duration at 50. People have asked me why I strictly try and use duration at 50. They've also tried to tell me that I am wrong and I should be looking at advertised, or I should be looking at advertised versus 50. And so let's go over why we use 50. Now, the first thing to realize is it's all we have. And it's probably not ideal. And we'll go over why here in a minute. But the advertised is even worse, because advertised could be at 6,000 tappet lift, which these days is getting more common, luckily. But it could be at 3. I have some listings that I've looked at that are at 1,000 tappet lift, which seems a little crazy. It could be at 12. I mean, it could be at, if it's solid cam, it might be at whatever the lash is, or it might be at 20. And so it makes it really hard to compare cams when you're thinking about horsepower and what you need by looking at advertised duration. Now, for the most part, we always have duration of 50. And that's one of the reasons we have that, is because way back when, it was hard to compare cams. So they kind of got together and said, well, let's use a standard of 50,000 tappet lift, and that lets us kind of look at cams and compare them from one company to another. Once you get comfortable in using 50, you can pretty well predict the behavior of the camshaft without too much trouble. But let's go over some of why maybe they say that, and why you do maybe need to kind of look at advertised, or you might even need to look higher up. Now, like I said, what you usually get is advertised duration and duration of 50. Now, some companies will also give you duration at 200. And so I have picked several cams here, and I just used the comp catalog. So they're all different families of cam lobes, but all from the same manufacturer. And I tried to pick cams that were very similar in duration, so we can go over what we're actually looking at. And I started with what they call a nostalgia lobe. And the nostalgia lobe, basic description, says that it's for early hot rod, still a little racy. I've used it a couple of times. I was always under the assumption it was about the slowest lobe they had, which meant the distance from advertised duration at 6 to duration at 50 was a bigger spread, slower coming on. That didn't prove to be completely true, which surprised me, which is one of the reasons why guys say to look at those two numbers. Because if we take a 265 cam in the nostalgia lobe, it is 218 at 50 and 124 at 200. And we'll go over why the 200 number is important. But let's just look at advertised and 50 for the moment. So if we go up to a high energy cam, the closest thing I've got is a 268. 268, 218. Now if you compare those two, you will see the duration of 50 is 218. And the duration at advertised, which comp uses 6,000s, is 268 versus 265. And so technically, the high energy lobe family is a little bit slower than the nostalgia. And I never quite realized that, because I never compared those two until I was getting ready to do this video. And so that kind of shows you why you really kind of need to look at some of that stuff. And it's not a big deal. I mean, it's a few degrees, but it does go to show you that if you're trying to be really friendly to the valve train and make sure that you have a slow ramp speed on the coming in, that's where you're looking at. Now, if you look higher up in the lobe. Because remember, ramp is down here at the very bottom. That's there to take up the slack in the valve train. Now, at the moment, I am talking about strictly a hydraulic lifter, and I've drawn it as a flat tappet. So we will get to some other choices here in a minute. But in a flat tappet, you have the lifter with its inside plunger, you have a push rod, the rocker arm, and the valve spring. All that has to be loaded up before that valve actually starts moving. And remember, in camshaft events, what you really care about is when that valve moves. You don't care about the actual number, you care about when it's actually going to move. Because if for some reason your particular application is taking a lot to load, it's either got way too much spring, the lifter tends to bleed down, or you don't have it quite set up right, push rod maybe is not the right length. I mean, you're hoping that everything is correct. And that's why that 6/1000 is used for the advertised duration. Because 6/1000 in like a small block Chevy is 9/1000 up here at the valve, 1:5 ratio rocker. But that's basically what they're assuming is the amount that things have to move before you've actually taken up the load. Now, it could be down at, 3 or 4. It could be maybe hopefully not, as high as 9. But the few thousands is where you're taking up the slack before the valve ever moves. And so that's why they picked that as opposed to like the one listing I said I have at 1, which is kind of crazy because that down there, certainly below the 6, is not going to do anything for making horsepower. There's just nothing there. And even at 6, remember, you've basically taken up the slack, but you haven't moved the valve. In order to make horsepower, you have to move air. The whole goal is to move more air. And if the valve is closed, you're not moving any air. And that's why I don't tend to like looking at advertised duration, because advertised up to 50, you're only maybe moving a little bit of air. Even at 50,000 tappet lift, remember this is tappet lift, 1:5 ratio, that's 75 at the valve. Now you've probably lost a little bit of that to taking up the slack, but if you look at a flow sheet, some companies won't even list 100,000 valve lift from flow bench data. They say it's irrelevant, it doesn't matter. And we're actually talking lower than that. If you take like a regular small block Chevy head, at 100,000 valve lift, it may flow, say, 60 CFM of airflow at 100,000 lift on a flow bench, 28 inches. But we're not even at that. We're maybe at 70,000. And so it may only be 40 CFM or so. And you also have to remember, as you just crack the valve, the air's not really moving. That's part of the reason why they say that even that 100 number is somewhat useless. It doesn't really, you can change that number, you can get a different cut on the valve and, not pick up peak, but maybe pick up real low end, and it doesn't always really change what you see on the dyno. It's not really impacting the horsepower because you're just not moving enough air yet. Now, there may be some onesie twosies, if you get real aggressive, it may become a few more, but it gives you an idea of why even looking between 6 and 50 isn't really a lot of help. I mean, it needs to be 50 at least in order to start understanding how you're doing and where you're actually starting to move air. Now, if we really want to get picky, where we got to look is probably way more up here. We're looking above 50. Now, say we have a cam that's 340 lobe lift, okay? Now, we're not talking that with the 1.5, that's like, what, maybe 510, I think it is. But you're looking really like halfway in between there. That's going to be really impacting the amount of air that you are actually moving in order to generate horsepower. And that's part of the reason why you have this 200 number, is that gets you up here so that you have an idea of what kind of duration you have at a much greater lift where you're going to be moving air. And that becomes more important. So really, rather than looking at advertising 50, we need to be looking at, 50 and 200. Ideally, maybe even if we had something in between those, but that data is not readily available most of the time, and so we live with what we have. But if we start looking at some of these different lobes with that idea of 6 versus 50 versus maybe 200, you start to get a much better picture of what the lobe actually is and where it's going to pick up speed or how fast it is. And the reason you worry about how fast is because that depends then on what your valve train is going to be like, how much spring pressure you need, whether or not the rocker needs to be a much sturdier design, whether you've got to go to shaft as opposed to just a stud mounted rocker, or you've got to go from your stock stamped steel rocker up to maybe something that's better quality, aluminum or some sort of steel rocker arm that has maybe even a roller tip, though we're not really talking about that part. It's more about strength, or whether or not you need to go up to that 80 wall push rod, or whether you need to be going up to a bigger diameter or a 120 wall. How rugged do you need to make this, because you've sped it up here in order to try and generate some more power. But let's start looking at some of the lobes, because like I said, what I'm looking at the moment is a regular hydraulic flat tappet, and that's some of the lobes I've chosen up here. I still do a lot of flat tappet stuff, and it is around. We will talk about rollers. But as we go up in what we have, you can see on my listing here, if I stick to about the 265, we already talked about the high energy, which is actually a little slower, sort of, because now we're talking about 200. If you look, the high energy lobe is actually a few degrees larger up here at 200. Well, wait a minute, we didn't see that when we were just looking down here. So what they've done is they've kept it pretty slow coming in, and then up here in the actual flank of the lobe, they've started speeding it back up. And that's why on the Nostalgia, it's actually a little slower in here. And that was always my understanding, is that it was supposed to be friendlier for older motors. I mean, that's why it's called Nostalgia. It was meant for a lot older ones where you don't necessarily have all these really nice parts to be able to run a really fast lobe. So they made it friendly, but it's interesting that they actually sped it up in here a little bit, maybe to give you the sound. I'm not quite sure why they're thinking, but then they kind of slowed back down in the 200. And that's why you need to look at all of these numbers to really understand what the lobe is going to do for you. Because in what we do, even if you have a custom cam made, you are not really the designer of the cam. You are picking a lobe out of a catalog. The company has somebody that has engineered the lobe, and that's the person that is really kind of designing the cam. What you're doing is trying to pick a particular lobe at a particular lobe center where it's ground to, in order to control the behavior of your motor. Because what you basically are is a camshaft behavioralist. You're not a camshaft designer. What you're doing is just picking lobes that already exist that seem to fit the need for how fast you can be and have the duration and lobe center to get the behavior you want. So as we start looking at some of these, you can see if we go up to like a magnum lobe here, and I've got the CompCam lobes listed, the actual lobe number listed. This is a 5201, so you can look these up, but that's 270. Now, that was as close as I could get to what these cams are, and certainly we're getting a little bigger, which is also going to impact the rest of the numbers just a little bit. So we've gone up a couple of degrees, but if you look, we've gone from 218 to 224. So even though we're only 2 degrees bigger at advertised, we are now 6 degrees bigger at the 50 mark. And so that goes to show you that when they tell you 6 and 50, that can be helpful, because you can see, if you see a difference here, normally it picks up more up here because they keep trying to keep a more constant acceleration going. Now, if you want to learn more about the actual lobe design, I am not your guy. I am the guy that picks them out of a catalog and works on what horsepower I'm going to make and how the motor will behave. If you really want to know more about actual lobe design, there is a YouTube channel, Powell Cams. Daniel Powell is really good. He's a real cam grinder, and he talks about what you can get away with and why there's a problem and what happens when you run into problems. And so if you want to learn about actual lobe design, you need to go to him. But let's keep talking about behavior and what we're seeing when we're picking a lobe. So once we get higher up, you can see, this was only 2, but we are now 7 up here at 200. So this lobe is faster and gives us more area on the lobe itself. And that area increases the flow, because basically the lobe in here is going to act like a bigger camshaft duration down here without you having the duration here. Now, you're going, well, why do I want that? I mean, can't I just go to a bigger lobe? And you may be able to. But there is some consequences with being bigger down here. When you start talking more duration down here, you start increasing overlap. And overlap at real low RPMs, you're idle, you're just off idle, depending on how the car's geared. If it's a street vehicle, you may care about 1,000, 1,500 as you're putzing around town going, 15 mile an hour. That can come into play down here with your overlap. And if you can keep the lobe narrower down here, but have more area under the curve, you can kind of have your cake and eat it too. You can minimize your overlap, but still have enough area under the curve to generate some more power. And so that is an advantageous part of going faster, and why cam companies have always strived to push things as best they could. Now, the other thing is the closing point on the intake lobe. This is exhaust lobe and intake lobe. Now, remember, at low RPM, if you're closing this later, if you add a lot of duration, well, that's going to also try and push back. It's called pulse back. That means it's going to try and push some of the air back up into the intake. Now, the reason it's doing that is because the valve is still open. We hold the valve open way past bottom dead center to try and get a better fill on the cylinder. So if you're really carrying that out, you won't have the airspeed to necessarily keep it from pushing back at low RPM. Now once you get to higher RPM, it does just fine. That's part of the reason why if you look at cams, as they go up in duration, they tend to say a higher and higher RPM. Now part of that is cycle time, which is a whole other video, but part of that is because as you widen this up, you are affecting the closing point and the overlap, which will affect the lower end power. Now if you're drag racing, if you're up in RPM band, you don't need to worry about 1,000. You don't need to worry about anything below 3,500 or 4,500. Then this is less of a worry, and you can certainly pump in a bigger cam and make it work. But if you're on the street, you've got to kind of worry about this stuff. And that's why you'll find people recommending smaller cams for street-driven vehicles. They may only recommend something that's 219 or 220 in order to try and keep this event and this event down so that your behavior at idle and off idle is really good. So when you're picking a cam, or if you're picking a lobe and a lobe center to figure out your behavior, this is some of what you have to look at. You're looking at your overlap, you're looking at your closing point, you're kind of deciding what can I get away with. I don't mind maybe running 2,500 stall, but I don't think I want to run more than that. Or I'm working on a truck, I need it to drive and cruise really nice, and I don't want to have a lot of gear in it. So then you got to really pay attention. Or you may be working on a drag motor, and you're like, well, I'm putting a 4,500 stall converter in it, so I could care less. Let's go to a big cam. So anyway, those are some of the decisions you have to make, and that's why you look at some of these numbers. Now, as we go up in these, if you look, in the dual energy, I found a 265, just like that nostalgia lobe that I started with. Now, if you're looking, this dual energy is 211 as opposed to 218. And it's 117 as opposed to 124. And so here we are again. I was thinking the nostalgia lobe was actually pretty slow, and I found out that I'm wrong by looking at it. Their dual energy lobe is probably one of their slower lobes. And that's why you do these exercises, to kind of see where you stand with some of this. And you have to kind of look back and forth at numbers when you're going through the catalog, or make a quick list of a couple of choices and compare them on a sheet so you can kind of see what you're dealing with. In some of the things I've done in the past, like I said, I have not used the nostalgia but a couple of times, but I would probably maybe go to the dual energy now that I realize it's actually a little slower. But you can judge how well you do. Something like this, of course, will be really nice to the rocker arm, and maybe that's what we need to do. If you've got just stamped steel rockers, stud mounted, they're not pinned, they're not screw-in, just a regular head, just a regular motor, well, then you stick to something that is slower like this so that it's friendly to the motor, and you don't worry about the fact that you may lose just a little bit of horsepower because you're a little slower in here. But that's something you give up in order to have it be reliable and run well with cheaper parts. That way you don't need all the expensive parts. Now, if we go up into rollers, because I know a lot of you are saying, well, flat tappet is dead. You're not going to do that. And as we go up into rollers, we can look and see what it gives you. And most people will tell you, well, you want to go roller, it's got way more area under the curve. Roller is way better. It can be way more aggressive, and you're not going to have problems because of that roller. Not really. Now, if we're talking about a hydraulic roller, if we go from this flat tappet up to a hydraulic roller, you're thinking the roller has a better time on the lobe because it's roller as opposed to the lifter just spinning. You know, because remember, this is not just sliding. These are spinning in their bore as you go. That's why they have taper. But the problem isn't that contact point. The problem is the hydraulic part of the lifter. If you move this too fast, you have trouble in the hydraulic part. Because remember, this is trying to take up slack when you're all the way down here on the bottom. And so it has to, as it loads, it has to lock a little check valve in the very bottom in order to stop the movement. If you jerk it too fast, it will squish some of the oil out, and then the lifter starts pumping down, and you start losing lift. So you can only go so aggressive and not mess up the hydraulic part. And the hydraulic part is the same whether it's a roller lifter or a flat tappet lifter. And so when you start looking at the roller lobes, you will find they are not a lot different. This high energy compared to the dual energy, now this is a roller lobe out of the Cam's book. Not that I'm picking on Comp, but the book was handy and it's fairly decently laid out. But 266, we're only 1 degree difference. But if you look here, this high energy is actually 210 instead of 211 at the 50. And we're only 116 compared to 117 up here at the 200. And so we have basically matched the same as this flat tappet, but we're a roller. And so you're not really gaining anything as area under the curve for the roller. Now you will have the roller, and some people I know have trouble with flat tappets, and so they may feel that they're better with the roller itself not eating into the cam. Now that still does happen, and we'll talk about that in a minute. But as we go up in rollers, you're like, well, that's just that lobe. We need a bigger lobe. Well, if we go up to a Magnum roller, you can see this kind of shows you why looking at advertised and 50 doesn't always paint a picture. Because we have two different lobes here. They're both 266. They're both 210 at 50. So from here to here, they're exactly the same. And then you go from 116 to 127. So once they got up here past 50, they started accelerating in here a little bit to give it just a little bit of an edge. And that one may work for you better because it's still kind of nice down here when you're first loading the hydraulic lifter. And so that's one thing you can look at, and you'll get maybe a little more area and a few more horsepower out of it. Now remember, these are not going to be day-night. It's not like a little faster cam is going to gain you 100 horsepower. That's not going to happen. We are talking small amounts. Cams and cam timing tends to be very subtle. That's why when you look at listings in books, you'll see, even in off-the-shelf cams, they usually go in 10-degree increments because it takes that to start seeing a difference. And a lot of times, I jump in 20s because it takes that 20 to really start making a significant difference. Normally, onesie twosies in degrees won't gain you much of anything except for maybe onesie twosies in horsepower. And I tend to like looking for bigger numbers. So as we go up, you're like, well, there are more aggressive lobes, and you're right. But if you look here, now if you notice, I stayed with 266 on all three of these rollers, which was easy to do in the comp book so that you could see what I'm talking about. Now, it is certainly more aggressive. It's 214 as opposed to 210. And it's getting up there at 129 as opposed to 127. So we're not only faster here, we're a little faster up here. And so that will actually help you in trying to decide what you want to do. This would be considered more aggressive. But I want you to notice, it is not hugely different It is a few degrees. It will make a difference. It might mostly make a difference down at like way low initial fill and not really change peak, but it's all going to be fairly subtle. So sometimes you've got to decide if it's worth it to go more aggressive and then have to worry about more valve spring, maybe a better rocker, going up to maybe a better push rod. And these are, like I said before, the choices you need to make when you're looking at these lobes. Now, one of the things I want to point out is if you get rid of that hydraulic part, if you go solid, if you're really looking to move this valve train and have something in here with some speed, then what you're really looking at is a solid or a solid roller. And so I picked one out down here. This is their extreme solid, 268 instead of 266, but you can see it's 230 as opposed to 214. And then it's 141 as opposed to 129. And that gains you more area in here because it's a solid. You're not stuck with having to worry about that hydraulic part of the lifter. And so that's why I always tend to push a solid cam with people that are really trying to make much more of a race motor. Now remember, as you're getting faster, your main gain is in here at TDC and at your closing point, because you can keep this small as this keeps getting wider and wider. Now, you can certainly add more duration and do the same thing if you don't want to deal with the speed. But then remember, you're dealing with overlap and what could happen with the overlap. So you can look at stuff and make your decisions. Now, I know a lot of you don't like doing lash. You know, I want it to be quiet. I will tell you that as you get some of these more aggressive cams, no matter if it's solid or hydraulic, they tend to be noisier. So if noise is one of your worries, you need to look at maybe doing a slower cam. Now, the other thing you can look at that will affect basically the same idea, and I have done this in the past to make the motor a little more friendly, is I will go with a slightly slower cam, something that's coming in here slower, but then I might bump the rocker ratio to 1/6 in order to pick the speed up here as opposed to down here. Now remember, it's still going to be slow in the initial loading down here, but then you pick up a little bit of valve lift and you get a little more. And that's the next thing I want to talk about. Valve lift. When you're looking at these, if you notice, I have not listed lift at all. When you're looking at these, one of the big advantages, and a lot of times where the horsepower actually comes from, is not the little bit of duration you're gaining in here, but the lift. As you speed this up, with that given duration, you can usually achieve a little more lift. And if you have a head that can flow up at those numbers, that can be advantageous. That extra lift can get you there. And you can keep the duration down to help your overlap, and you can generate a little more power that way. So as you're dealing with stuff, if the head you have chosen is better at 600 or 700 than 500, then you want to probably look at maybe a more aggressive cam. And if you can live with doing the little better parts, you know, better valve, better spring, better rocker, better push rod, you know, maybe even a better lifter, you can deal with all of that and get a little more in between. Because sometimes our goal is trying to generate more power without impacting the motor's behavior at real low RPM. And that's where a lot of this comes into play is, you know, where am I impacting the motor? Am I gaining high end? It's not all about that big number at the top. It's really about how the motor is going to behave and if I can get that horsepower without having other problems. And so that's why I tend to look at 50 just in general, and then if I really am getting into it, if it's a bigger build, I try and see if I can find a 200 number, because I really prefer to look at 50 to 200 rather than advertised or 6 to 50 as a more indicator of how quick that particular lobe is and if I'm going to be okay with it. Now the other thing is, even if you're not designing your cam, if you start looking at some of the lobes in the lobe catalog and you crunch some of these numbers, you'll find that comp will list off-the-shelf camshafts in that family. They will list a dual energy, they will list a magnum, they will list a high energy. And if you kind of understand where it is speed-wise, even if you're using an off-the-shelf cam, you can say, oh, well, I can pick this one, I'll pick out of this section because that's kind of got the speed, because I'm okay with a rocker, but I don't want a killer spring. I want to run stock push rods. I want to run an inexpensive roller. I'm not looking to run a very expensive shaft mount. And so these are some of the things you can decide even with a off-the-shelf cam, if you start understanding basically how fast the particular lobe is, and don't necessarily go to just this is the bad boy one, I want to run it. So that's why I use 50, and that's why I tend to talk in 50. Once you kind of get comfortable with how the motor will behave, because a lot of it is about down here with behavior. It's about the closing point, it's about the opening point. It's less about this, is more about power. You will gain a little bit with duration here. You will certainly gain if the head flows more, but behavior-wise is usually down here. So I work in the 50s. It makes me comfortable, and that's why a lot of my videos I say I work in 50. I say that mostly just so that you understand where I'm talking about, what number I'm talking about. And like I said, advertised is somewhat ambiguous. It doesn't completely help. So that's how it goes. Let me know in the comments what you think. If we need to talk about overlap and closing points, we can. I have done some videos on inertia RAM, which is in the playlist for all these chalkboard videos. There are certainly more videos that I can do and things that I want to pass on with what I've learned, and that's why I work at 50. It's just easy for me. I wish all your projects go well, and have a good day. Bye.